sometimes it's a hassle to assess whether something is valid or not. So what can help is recognizing specific forms of deductive arguments, as you can sometimes encounter them. And I'm going to point out a couple of these examples as they're mentioned in the book as well. First is an argument by cases, which in symbols would mean either P or Q is true. If P, then Y. If Q, then Y. Then it's necessarily the case, if we assume the first three premises to be true, that Y is true, the conclusion is true as well. Which sounds a bit abstract, but it's actually what we did last week when we talked about the problem of, is a married person looking at an unmarried person, right? I told you John is looking at Bobby, Bobby is looking at Jimmy, John is married, Jimmy is unmarried, and we don't know whether Bobby is looking at Jimmy or not. And then you said, well, we can't assess whether a married person is looking at an unmarried person, but then you realized, well, there's just two possibilities. There are just two possible cases. Either Bobby is married or she's not married. So, that's our first premise. Bobby is either married or not married. The second step in our deductive argument is, if Bobby is married, then a married person is looking at an unmarried person, right? We saw that in the first example in blue. If we then assume, go to the second possible case, sorry, I'm just finishing my thought here. If Bobby is married, then a married person is looking at, the third premise should be, if Bobby is unmarried, then a married person is also looking at an unmarried person, which is the second case here. Then we would have to conclude that the conclusion holds. So a married person is looking at an unmarried person, because we know that that conclusion holds in all possible cases, which is an example of an argument by cases. Sorry. Back to types of argumentation. What can help you in assessing a deductively valid, or whether an argument is deductively valid, is checking whether you recognize any of the classical types of argumentation, the first of which is argument by cases, which we actually already intuitively used last week. Other types are a disjunctive syllogism, in which you say either P or Q is true, and you deny one or the other part of the disjunction. So that implies that the other part needs to be true, right? Because the only way whether P1, how P1 and P2 can be true is for the other part to be true. So to make it somewhat less abstract is that if you say I dance or everyone dances, and you then deny the right part of that statement, that means the left part of the statement would have to be true, right? Because if you assume that P1 is true, that means that either P or Q or both are in fact true, and then you say P2 has to be true as well, in which you deny that Q is true, then it is logically, the logical consequence is that P has to be true. Another argument that you're going to encounter a lot is a chain argument. So in which you tie together two if-then statements. If P then Q, if Q then R, if P then R. It's a chain argument because the premises are linked here, right? So this conditional ends on a Q, and this conditional starts with a Q, and this conditional ends with an R, and this conditional starts. This conditional summarizes both ends of the chain. So if P, then R holds, because the Q is actually the link in the chain that connects them. All right. An example would be, when I dance, everyone dances. When everyone dances, Swayze sings. I dance, so Swayze sings. Logically holds. If P1 and P2 are true, the conclusion would have to hold as well. Again, you can clearly see what I meant with the fact that it's a safe inference, right? You can clearly see that all information in the conclusion is included in the premises as well. All right. Two other arguments that you should learn to recognize are the modus ponens and the modus tollens, which are two forms of valid reasoning, which are again related to that conditional statement, if P then Q. First of all, when I dance, everyone dances. I'm dancing, so everyone's dancing. If P, which can be summarized in symbols in the following way: if P then Q, P therefore Q. So if P1 and P2 are true, the conclusion would have to be true. And the counter side of what's implied by that conditional statement is when I dance, everyone dances. Not everyone dances, so I don't dance. Again, is a valid form of reasoning. If P then Q, not Q, then not P. For now, it's important that you recognize these forms. So if you're saying what you're thinking, all right, I'll take your word for it, right? So the one is valid and the other isn't, or these two forms of arguments are valid. That's a step in the proper step in the good direction, right? So if you learn to recognize forms of valid argumentation, you already know if you spotted an instance of this argument or that argument, you can say that it's valid. So that helps. It's a shortcut in assessing validity. Let's see. For example, if I would give you this argument, right? Let's just ignore what it says at the top, right? So I wanted to give you a different example because of you guys being awesome, as I said at the beginning of the lecture. I changed it to, if you're currently enrolled in SSR, then you're an awesome student. You're currently enrolled in SSR, so you must be an awesome student. One way of checking for the validity would be assuming if P1 and P2 hold, does the conclusion necessarily follow? But perhaps you've recognized that argument for we just talked about. If P, then Q, P, so Q, which is affirming the antecedent, which you can learn to recognize if you learn it by heart. All right. So finally, before the break, we'll get back to the example we talked about last week, right? So it's the Wason selection problem, in which you get a stack of cards and you get a rule which you need to test. I just put up a different rule. We have a stack of cards with Pokemon on the front and singers on the back. Test the rule. If there's Squirtle on the front, Rapper Source is on the other side. Again, the type of problem is the same as last week. I'm just giving you different examples, a different rule to check now. Anyone wants to give the answer? Justin Bieber and Squirtle. All right. Raoul, why do you think Justin Bieber and Squirtle?
We have to turn Squirtle to see if the rapper is on the backside. Mm-hmm. And Justin to see if maybe Squirtle isn't on the backside of Justin to falsify the statement.
Yeah, indeed. Thank you. That's an excellent answer. It's the correct answer, and that's the correct justification as well. The reason behind, or the logic behind those correct answers, or the logic behind why we need to falsify that statement, as so indicated, has to do with that same conditional we talked about. So if P, then Q, because it's included here as well. So saying that if there's a Squirtle on the front, Rapper Source is on the other side, can be translated to if P, then Q. We know from studying those different valid forms of argumentation that two possible valid forms of argumentation can be constructed from this rule, if it were true. We can affirm the antecedent, right? So we can say if P, then Q, so we confirm P, and then the conclusion Q has to hold, which is what we do with the cards, right? So it means in terms of the cards that we're flipping, if there's a Squirtle on the front, there has to be a Rapper Source on the backside. That's a logical implication of the first premise, which is what we're checking by flipping the Squirtle card, whether that logical implication holds, which is one way of checking that first logical rule. Another logical implication of if P, then Q is that, I'm sorry for this, not Q, not P. I'm sorry, I forgot to change this part of the slide. It's the other part, right? So we know that we can deny the consequent, or denying the consequent would mean we have to deny the antecedent as well. If we deny Q, we have to deny P as well. So if P, then Q, if there's Squirtle on the front, Rapper Source is on the other side, we can check whether the rule holds by indeed checking if it's the case that Rapper Source is not on the other side, there's indeed not a Squirtle on the front as well. All right. So you could summarize that reasoning that brought us to which cards we need to check as the following. We know that if P then Q holds, then we know that if we see a squirtle, wrapper source needs to be on the other side, and we know that if the wrapper is not on the other side, squirtle can't be on the front side as well. And that's the only two logical implications of the rule being true. So it only makes sense to flip this card, and it makes sense to flip that card, and it doesn't make sense to flip the other two cards because it has no logical implications for the rule being true or not, which all has to do with that conditional statement, which is perhaps a bit obtuse if you consider these abstract entities, right? It makes more sense if you consider stuff you're familiar with. So what makes logical reasoning often difficult is that what I just mentioned, right? So the content is not always relevant in checking whether the connection between the premises hold, the propositions hold. And sometimes the logical relationship expressed by if P then Q accords with what we know to be true in the world. So if I'm saying that if it's raining, then it's cloudy, you're very familiar with that logical relationship because it's the same as the way you've encountered rain before all your life, right? So if I'm saying if it's raining, then it's cloudy, then it's very intuitive for you to think that as soon as you look outside and you see some rain or you feel that it's raining, it's guaranteed to be true and that there's clouds, right? And you also know that if you look outside and there's no cloud to be seen in the sky, that it's guaranteed to be true that it's not raining. And that's the exact logical relationship that if P then Q implies. So sometimes it makes more sense you could also substitute anything anyone is saying when they're saying if P then Q with rain and clouds to make it more intuitive for you to assess. Because it's easier for you to know that, indeed, as I mentioned, so if P then Q, if we're referring to if it's raining, then it's cloudy, it's intuitive for you to know that if you see it raining, it must be cloudy, and if you see a clear sky, it must be not raining. And you also know that the other two options aren't necessarily true, right? So if it's cloudy, it doesn't necessarily mean that it's raining. And you also know that if it's not raining, it doesn't necessarily mean that it's not cloudy, right? I think this example is intuitive for everyone because how you know the relationship between rain and clouds to be is the same as the logical relationship expressed here in the conditional statement, if it's raining, then cloudy, or then clouds. All right. Which brings us to the first hint of what the logic is behind the statement that we should try and falsify our statement. Because if we try to verify our statements, we get something like this. If my theory is true, then this observation, then my theory is true. Here we would be confirming the consequent of the conditional, which is not deductively valid. So trying to confirm the consequence of that conditional has no certain logical implications, right? If we learn to recognize. In the same way that knowing that it's cloudy doesn't necessarily mean that it's raining. Seeing that your observation, your predicted observation occurs doesn't necessarily mean that your theory is true. It's the same logical relationship. And for the same reason that you're not going to say, hey, it's cloudy, so it must be raining. For that reason, you can't also be saying that, hey, my prediction holds, so my theory must be true. All right. And you can put that in the same diagram I've just drawn, which is in the Willingham chapter from last week, which should make it easier to recognize the different valid and invalid forms of reasoning with conditional statements. The only thing they're trying to point out there, so I'm summarizing here, Daphne, is there are two types of claims that people can make, either prescriptive or descriptive. Prescriptive claim is saying you should do such and such, or we should take this measure, or we should do that. And a descriptive claim is just describing something. People are doing this, or people are doing that, or I am doing this. And what they're trying to say in this chapter specifically is that we can treat both descriptive as well as prescriptive claims similarly, which means we can say both of prescriptive claims that they're either true or not, and we can say that from descriptive claims as well, they are true or not. So if I'm saying I'm dancing the Macarena currently, right now, you could say that statement is false because you're clearly sitting at your desk, right? So that would be me making a descriptive statement and you saying it is false. So together we're factually assessing a descriptive statement. We can do the same with a prescriptive statement. You could say, Roland, you should dance the Macarena right now. And I could say, no, I shouldn't, because that would confuse people and my camera isn't properly attuned for it, or something like that. So what you did was making a prescriptive claim, and I'm saying, doing a factual assessment of that claim. I'm saying that claim is false. And the only point the book is trying to make is saying, well, for both type of statements, you can assess the truth value. That's basically it. That's all you need to know. No, they will not resemble last year's exam. So for sure, there will be less multiple choice questions than you're used to. There will be more open format questions, either fill in the blank questions where you have to fill in a number, for example, or a word, and a couple of essay questions as well. Yeah, I'll post the exact breakdown of type of questions before the exam. And for now, I can say that the percentage of questions you will get from each topic, so the percentage of questions about statistics and the percentage of questions about the other stuff, will be in the same proportion as the lectures. So this block, you will have 6 lectures about the other stuff and 4 lectures about the statistics part. So that 60-40 breakdown will apply to the questions you get in the exam as well.